Hey folks, welcome to my channel number 10. So there we have the problem on the screen. Integrate the following with respect to x. We have 1 divided by square root of x square minus 4x plus 5. So what we've been given is dy by dx and we've been asked to find y. My y is nothing but integral of the given expression. So let's write down what our y is. So that's my y, and I do see that my y is not in a very simple format whose antiderivative I know from first principles. But then when I take a closer look at y, I see that I have a quadratic expression inside the square root, right? And whenever you have a quadratic expression and you're being asked to integrate with respect to x, the technique or the thought process that you should adopt is, can I reduce this quadratic expression to a format x plus or minus a the whole square plus or minus b square, right, where a and b are constants. And when I take a look at this, it doesn't look like it's very difficult. So let us do one thing. Let us just pick the quadratic expression inside the square root, write it down separately, and try to arrive at the format that will help us integrate this easily, right? So I'm going to keep y aside for a bit. So x square minus 4x plus 5, right? Now I'm going to use the formula which is uh, quite a popular one in algebra. We know that a plus b the whole square is equal to a square plus b square plus 2ab. And similarly, a minus b the whole square is a square plus b square minus 2ab, right? So the formula that we are going to adopt here is the second one, which is a minus b the whole square. I write my x square as it is. My 4x is nothing but 2 times 2x, right? And imagine if I add and subtract a 4, that is not going to change my expression. Then it gives me an opportunity to rewrite my expression in the manner which I just now mentioned to you, right? Let me highlight the first three terms of this expression in yellow, which means I have an x square minus 2 times 2x plus 4. And what is that? Again, go back to the formula. A minus b the whole square equals a square plus b square minus 2ab, and therefore the portion highlighted in yellow becomes x minus 2 the whole square, right? So this entire expression, using the algebraic formula, I am able to reduce it to the format that is going to help us integrate this easily. So this is what we have. So my x square minus 4x plus 5 is nothing but x minus 2 the whole square plus 1. All right. So I go back to my y and I replace my quadratic expression what I have with x minus 2 the whole square plus 1, right? And then let's see how we go about solving this particular problem. My y has integral of dx divided by square root of x minus 2 the whole square plus 1, right? So I know that with the substitution t equals x minus 2, I will be able to bring it off the format integral of dx by square root of x square. This time it is plus a square. So far we have seen problems of the type integral of dx by square root of x square minus a square. I'm referring to the couple of the problems we solved in our recent videos, but in this particular problem we have integral of dx by square root of x minus 2 the whole square plus 1, right? Therefore, when we make the substitution t equals x minus 2, we will be able to arrive at integral of dt by square root of t square plus a square, where my a is equal to 1, right? So let's do that substitution. T becomes equals to x minus 2, which means my dt equals dx. I go back to my y, put back everything in the form of t, and let's see what do we get before we move to the next step. So my y becomes integral of my dx becomes dt, right? And my term inside the square root now becomes t square plus 1. And what is my 1? My 1 is the same as a 1 square, right? So I'm going to write this as t square plus 1 square. This is where I want you to connect it with one of the basic trigonometric identities that we are familiar with, right? So we are familiar with sine square theta plus cos square theta equals 1. We are familiar with secant square theta minus tan square theta equals 1. And we're also familiar with cosecant square theta minus cot square theta equals 1, right? So here again, the substitution will be t equals 1 times tan theta, right? And let's imagine in place of 1 square inside the square root you had 2 square, then your substitution would have been t equals 2 tan theta. Now when you have t equals 1 tan theta, which is nothing but a tan theta, then your dt becomes equal to secant square theta d theta, right? And this is something that I expect you to know from first principles, right? So what happens to my y now? I go back to my y and try and represent everything in terms of theta, right? So let's do that in the subsequent step. So my y becomes integral of my dt, which is there in the numerator, becomes a secant square theta d theta. So let's write it as it is. And then what I have in the denominator is the square root of t square plus 1 square, right? Now what is my t here? It is tan theta. So my t square is tan square theta. I have 1 plus tan square theta, which is nothing but a secant square theta. And then I have a square root of secant square theta, which becomes a secant theta, right? I hope you folks are with me. And it's very important that you make the right substitution so that you don't get stuck in these problems, right? So what you have now is secant square theta in the numerator and a secant theta in the denominator, which means I can cancel out the secant theta in the denominator and I'm left with integral of secant theta d theta, which is not very difficult and I expect you to know this by now. And it's nothing but log of secant theta and theta. And those of you who are wondering how did I arrive at this, kindly take a look at the video for integral of secant x dx. I've put a link to that particular video in my description. So what we have is log of mod of secant theta plus tan theta plus c. And imagine we started solving this problem with y in terms of x, right? So I'll have to put back everything in terms of x. So what is that substitution that we'll have to make? We made two substitutions, and the most recent substitution that we made is t equals tan theta. So let me go back and put back everything in terms of t first before I come back to my x, right? So my secant theta is nothing but a square root of 1 plus tan square theta, right? So what happens is my secant theta, which is the first term inside my log, becomes a 1 plus t square, right? I hope you folks are with me. And then I have a plus tan theta, which is pretty simple. So I'm left with log of mod of root of 1 plus t square plus t, right? And then I have my constant plus c. Now I go back and take a look at what is that substitution that I originally made, right? Let me highlight that in yellow for you folks. So my t equals x minus 2, and let me put back my t in terms of x, which is not too difficult. So there we are, post replacement of t with x minus 2. So this is my final answer to this problem. And in case you want, you can definitely expand x minus 2 the whole square and then rewrite your answer. It does not change the answer in any way. So let's do that as well. So there we have log of mod of x minus 2 plus square root of x square minus 4x plus 5, all within the log plus my constant c. Let me highlight my final answer in pink. There we are. I hope you found my content useful. Please do subscribe to my channel and support. Thank you.